Hello, welcome to the 11th week counseling session of the course Finite Element Method, course offered by NPTEL. Course instructors of this course are Professor Vishwanath Banerjee and Professor Amit Shah. And myself, Asif Prada, I am a teaching assistant. I am a PhD scholar from Department of Civil Engineering, SC Bangalore. So today we'll be discussing initially the questions relevant to assignment number 12. And the questions which I have is like exactly assignment 12. So I'll try to modify those questions and ask you guys to give me your guesses, or I will get in the meanwhile. And then we'll discuss the solution of assignment number 10. Sorry, assignment number 11. So let's start. Okay. So first question is, consider the 8-node rectangular prism element in three-dimensional domain. Coordinate axis is the center is at the center of the element. It extends minus L12 along x-axis, minus B to B along y-axis, and minus S to H along z-axis. Identify the proper shape function for different nodes. And the first question is, what will be the shape function of node 3? And yeah, the question, this is like the question, what will be the shape function node 3 is already there in assignment number 12. So instead, I'll ask what will be the shape function of node 7. So out of these four options, what do you think? What will be my shape function for node 7?
Okay, let's think about this. For the 7 node, we have z minus uh, what is the height of this h?
Okay.
Minus h over
Along
2.
al- along x-axis, it's from minus L to L, that is 2L. Along y-axis, it's
Okay,
2B, and along z-axis, it's 2H.
for the 7,
So first,
uh,
what will be the coordinate for node 7?
we have here is
See,
equal to 0.
it's located here. So it's uh, what will be the x coordinate? It's in the positive side of the x-axis, right? It's visible to you all, right?
Yes.
Okay. So the first, what will be the coordinate? Node 7 of the node 7. It will be
It will be
L.
oh,
In the positive side, it's L.
L
Then L,
H
comma B, B, B,
comma
first
H.
Y, and then comma
Yes,
H.
sorry.
Yeah. Yeah. So now, uh, as we do normally, first we try to just substitute and see using elimination method which option would be the correct answer. So if we substitute, say, in this all four options, L, comma B, comma H, and see what is the answer. So if we substitute in the first option, L, comma B, comma H, so here we get L, B, H. Here we get directly 1. Here we get 0. Here we get uh, L,
1. Sorry, 2,
2 to the 4 to the 8
4.
to 4. And here we get 0. So we can say for sure the correct answer would be option A, isn't it?
It is.
Now, trying to solve it conventionally, more traditional way. So if we see our node 7 is here. So apart from this, we need to uh, uh, say we try to see this space, then space, I'll just say space of 1256, 1256, then uh, then the down, this one, 1234, space 1234, and this one, space 1485. So along these spaces, my safe function of this node 7 will give value equal to 0, right? So uh, how do you normally calculate it? Along 7, along this space, along this space, it will be 1 by 2, or it's only in the variation of uh, it's along in the variation of x, right? So this is equal to x equal to minus L. So here we just do x plus L, uh, x minus L, and value is L minus L. So this is for this one. Okay, then this will be equal to x plus L upon 2L, that is 1 by 2 1 plus x by L, right? This is for this. Now let's see for this case. 1, 2, 3, 4. 1, 2, 3, 4. It's at the down, and the variation is along z direction, and the equation for this case is z equal to minus h, right? So this will be giving me z minus h, and the value of node 7 is h minus h. This will be z plus h 1 to h, that is 1 by 2, and plus z upon h. Okay, and due to this phase, the question for this phase is 1485. 1485 is this one, that is y equal to minus b. Y equal to minus b. Right? The equation for that will be y equal to y minus b upon, we have b and minus b. This will be y plus b upon b, that is 1 upon 2, 1 plus y upon b. Okay, so finally, what will be my safe function for uh, node 7? It will be just the product of all the above, that is 1 by 2, 1 plus x by L, 1 by 2, 1 plus z upon h, and 1 by 2, 1 plus y by b. And arranging it properly, we get 1 by 8 plus x by L, 1 plus y by b, 1 plus z by h. Okay, so this is, uh, I hope nobody else out. Yeah, Rafael has already given a good one. Now, let's do, there's a question asked in the assignment is for node 5. Let's do for our case node 8. So here, node 8. Okay. node 8, and node 8 is uh, in the positive side of the x-axis, on the negative side of the x-axis, sorry, y-axis, and on the positive side of the z-axis. That is, node 8 is having the coordinate system is L minus B comma H. So tell me, what will be the answer? Will be minus in front of y. Yes. So we still have two options, B and D. Okay. I see no options matching. Is it? Let me see. Let me check. L comma minus B comma H. So if we substitute here, L, this will give me 0. This will give me 0. This will give me 0. And this will also give me 0. So out of these, no options are correct. So let's try to find uh, what will be the answer corresponding to node 8. What will be the step function? So as you said, that it's similar to node 7, except that on the y part it will be negative. So earlier, uh, so first phase, second phase, it would be same. Phase 1, 2, 5, 6. 1, 2, 5, 6. Phase 1, 2, 3, 4. Only this phase will change corresponding to y, and that is 2, 3, 7, 6. 2, 3, 7, 6. Okay. So corresponding, as we have already solved for this, we get 1 by 2, 1 plus x by L. For this, we get 1 by 2, 1 plus z upon h. For this, as you see, this is for the case y equal to minus of b. Yeah. Oh, let me see. No, y equal to plus b. So if we try to solve it here, y minus b and minus b, this will give me 1 by 2, 1 minus y upon b. Okay, so with this, we get phi 8 as 1 by 2, 1 plus x by L, 1 by 2, plus z by h, and 1 by 2, 1 minus phi by b. This will give me phi 8 as 1 by 8, 1 plus x by L, 1 minus y by b, and 1 plus z by h. Okay, so this is the answer. Okay, quick question. What if I change uh, everything here? It's like everything question is from minus L to L, minus B to B, minus H to H. So what if I change the question and just say minus L by 2 to L by 2, minus B by 2 to B by 2, and minus H by 2 to H by 2? Or rather, okay, I'll make it more complex. Along x-axis and along y-axis, it is minus L by 2 to L by 2, minus B by 2 to B by 2, and in z-axis, it is minus H to H only. I'm just saying it along x-axis, it's minus L by 2 to L by 2, y-axis, it's minus B by 2 to B by 2, and along z-axis, it's minus H to H. So what will be the answer corresponding to these changes? What changes can be expected? You can quickly guess. Rafael, are you there?
I'm here.
Yeah, so quick.
The faces will be the same, but
Yeah,
coordinates for them
everything
will
is
be
same.
different.
Yes,
Yeah, the faces will be the
yes.
same. So
So
we put in the answer different coordinates, other
yeah,
coordinates. For instance,
so
for number 7, we will substitute x minus L over 2, L over 2 minus L over 2, for instance.
yes. No, but that I know that will be done. But I'm asking, what will be the final answer? Quickly, I'm just saying. Like, can you guys guess it quickly?
Quickly. Uh,
See? So along x-axis, it's x minus L by 2, and in the at the denominator, it's minus L by 2 to L by 2 minus of minus L by 2. So down it will be what? L only, and in the top it's x
I
plus
believe
L by
it will
2.
be different 2x over L. It will be 2x over L, 2y over b.
So we're saying 2x. Uh,
2x over
okay,
L,
so
2y over b.
you're just saying 2x this thing, right?
Yes, 2y over b and 1z over h and
What
1
about
eighth.
the constant
1
outside?
eighth, yes.
1/8. Let me see. So this will become x plus L by 2, and this is L only. So we'll get 2x plus L by 2L. 1 by 2, and we have 1 plus 2x by L. Yeah, okay, you're correct. Yeah, so this will be 1 upon 8. So similarly for 5/8 will be, so we are just changing x. uh, we have to make changes only along x, right? So for that 5/8, I'm just writing prime. That will be 1 plus 2x by L, 1 minus 2y by b, and 1 plus z upon x. Okay, easy. We can move on. So this is a common textbook question number 3 to 4. Consider a tetrahedral element with nodes 1, 2, 3, 4, and P point is inside the element. Uh, you can see here. So question number 3 is, identify the incorrect statement corresponding to the element. First statement is, location of the position P can be written with the help of tetrahedral coordinate system xi1, xi2, xi3, xi4. Statement B is, xi1 equal to 1 at node 1 and xi1 equal to 0 at surface and by nodes 2, 3, 4. Option C or C statement is, at point P, xi1 plus xi2 plus xi3 plus xi4 equal to 0, there will be the volume of the tetrahedron. I can be considered safe function as it follows the partition of D property. So what do you think uh, is the incorrect statement and correct answer corresponding to this question? So quickly, everyone. This is a
I
tetrahedral
cannot see
coordinate
the,
system. We have
the
already
fourth
discussed
option.
earlier.
I cannot see the fourth option,
Okay,
but
I'll do.
I can check that ABC is correct. I believe ABC is correct.
I zoom in. Are you able to see the fourth statement now?
Yeah.
Yeah. Okay. So, according to this option, C is the incorrect statement. And what about Rafael? You're saying A, B, C are correct. So, according to you, option D should be incorrect. Is it?
I also
Yeah.
think like Raphael. ABC is correct, but D,
So, Abdullah, you are also saying option D, is it?
yes.
Okay. So, we have three. This has said option C, while Abdullah has said option D. So, okay, let us check one by one. Location of the point P can be written as the tetrahedral coordinate system. Xy1,
Could you
Xy4,
explain what does it mean?
and
C
this
zeta I can be considered as a shape function. What does it mean? Oh, it's tetrahedral coordinates. It's like triangle coordinates, like
yeah,
right?
yeah.
And then for C we should have 2V.
You've already
I don't know. I'm not sure about this. Sorry about that. Okay, my guess is D. Yeah,
no,
yes, sure. Some should be the one.
no.
Gis can
Okay,
Gis can
yeah. So answer is
Gis you
actually option C only. Plus Xy1 plus Xy2 plus
yeah.
Xy3 plus Xy4 is equal to 1 actually. And this is only what is partition of unity that as you all know sum of safe function Ni as you guys have studied it is equal to 1. That is like partition of unity only. So let's see how is it being done here. Okay. Uh, okay, so Xy1, Xy2, Xy3, Xy4, these are like in tetrahedral coordinate system. As you guys have already, I told you the triangle coordinate system. Okay, let's see. Xy1 equal to 1 at node 1 and Xy1 equal to 0 at surface spanned by node 2, 3, 4. So Xy1 is what? Safe function if I treat, uh, okay, let's see. What will be Xy1? Rather, I'll just draw here. Connect this thing, this one, this one, this one. Okay. So, connecting this uh, point P to each of the nodes will divide this tetrahedral to four tetrahedral again. Okay. So if I treat, okay. So let's see, how should I say? Xy1, okay, V1, I'll say V1 would be the opposite one. So V1, V, yeah. So V1 is the volume into
I believe we need to again
let's say
use
P 2, 3, 4. Please look this. So V1 is the volume of the tetrahedron formed by point P 234. Like similarly in the triangle, what was happening? In the triangle, if there was a coordinate P and this is 1, 2, 3, we joined this. So area A1 was what? Triangle formed by all the nodes except node 1. So P 2, 3, isn't it? So this one was A1. Okay. Similarly, we have to do for this. So V1 would be the tetrahedron. Okay. So V1 is volume of tetrahedron formed by P 2, 3, 4. Similarly, V2 would be what? Volume of tetrahedron using P341. P3 would be volume of tetrahedron P124 and V4 would be volume of tetrahedron P123. Okay. Now, what will be Xi1? Xi1 is equal to V1 upon V. Xi2 would be V2 upon V. Xi3 would be V4 upon, V3 upon V, and Xi4 would be V4 upon V, where V is the volume of tetrahedron 1, 2, 3 4 formed by this. That means the complete tetrahedron, which is the given one. Okay. So now if you see, for this, Xi1 equal to V1 upon V. So second statement says Xi1 equal to 1 at node 1 and Xi1 equal to 0 at surface spanned by nodes 2, 3, 4. So if Xi1, if I am at node 1, that means my node P is at 1. So what will happen? Will get the volume address P2 is actually 134. P coincides with 1. V1 is equal to V, that means V1 is equal to 1. Right? And V1 equal to 0 at surface spans by nodes 2, 3, 4. So that is also correct. Like besides this, at surface spans by the if my the node P or the point P is at the surface spanned by 2, 3, 4, we actually have a flat surface. We don't have any 3D volume. So that will give me 0. So second statement is correct. Third statement is I1 plus I2 plus I3 plus I4 is equal to that is actually just a slight change need to be done there. I1 plus I2 plus I3 plus I4 that is equal to C V1 by V plus V2 by V plus V3 by V plus V4 by V, and this is V1 plus V2 plus V3 plus V4 by V, that is V upon V is equal to 1. Okay, so so only the third statement is incorrect. There it should be sum of I is equal to 1. And first statement is I can consider as a function as it follows the partition of unity. So that is also correct. Rafael, you have quite a lot. Rafael has said 1 by 3. What is 1 by 3?
It was my mistake.
Rafael?
It was my
Okay.
mistake.
Okay. So I hope this question it's clarified. Nobody has doubt. Make confirmation. Okay. Rafael has already confirmed. This was already correct. Abdullah, can I move on to the next question?
Yeah. It's clear, actually. It's clear.
Yeah, okay. Thanks. So next question is quickly we can do. So fourth question is, suppose volume of the tetrahedron is V and we are interested to find the xy1 coordinate in tetrahedral coordinate system of point P. What will be the xy1? Actually, I have already written down. So rather than I'll just ask what are these values? If I ask you what is this value, what is this value, what is this value, what is this value? So first one, I'll ask arbitrarily. Each person can say. So first, Abdullah, what will be the first?
We just see
Don't
what's
see
the
the
number.
left hand side.
The number is missing, like the first option.
So
We have P1, 2, 3, then it's 4. Because it's the opposite of 4. So it's xy4.
Therefore, yeah. Okay. Next is this.
Next is like the missing is 2, then it's xy2, I think.
Okay, I was asking this to answer this. Okay. Okay, you can give all the answer now. Jay, you want to then third and please give the answer.
Yeah,
Sorry.
C, it is psi1.
Yeah. And D.
One, two, three, four. So that's total volume.
Nice.
Yeah.
So 1.
So
1.
yeah. Okay. Yes. You are correct. Answer is 1 for this. Okay. I think this thing is clear to all now. Okay. Let's move on to the next question. This is also there in the assignment. I think I am helping you guys to give the answers to the assignment. Okay. The question is one isoparametric mapping is shown in the figure. In the mapping function, f maps any point xy eta zeta from parent domain to xyz on physical domain. What will be the Jacobian of this transformation? And this parent domain system has the coordinate system -1 to 1 for all the three xy eta zeta coordinate system. So we have all these 4 options. Yeah, zoom in if you guys have issue to see. What do you think? What will be the correct option? Rafael is saying A or B. Abdullah said A. This. This has also said A. Okay. So, okay. So you guys agree on elimination of option C and D. As we can see the dimension itself, like it's not 3 by 3, it should be 3 by 3 because we are mapping everything from 3 coordinate system to 3 only. So it should be 3 by 3 only, isn't it? So this C and D won't be there. But now there's a confusion that A or B. So we should differentiate this. So A. Yeah. So the mapping is taking place from point Z, like from parent domain to the physical domain, right? So our new coordinate system in that perspective is x, y, z, and old coordinate system is zeta, zeta. Okay. So x, y to zeta, zeta. So we should differentiate x, y, z. Okay. In this, like everyone is agreeing that option A is the correct answer, but we should see like why is it the correct answer. Let's see. So if this thing, first thing first, like if it has been a 1 by 1 coordinate system, okay, so it would be kind of like dx is equal to dou x by dou xi dxi, right? And this is equal to what? Uh, dxi, because our our uh, new coordinate is like normally Jacobian. Like if you take the determinant of the Jacobian, it's it is equal to new volume upon original volume. I'm talking in the perspective of solid mechanics as well. Like this is what we normally do. Like if you guys remember determinant of Jacobian deformation gradient. Okay. So in this perspective, our old coordinate system is this dz coordinate system and new coordinate system is dx. So in uh, this would be what? Dx upon dz. Right? So this is quite easy. Let's see for 2 by 2. If we have 2 by 2, so there our dv would consist of both determinant of dx and dy. So if I write this thing, and this is domain, and this would be, if I write this in the vectorial form, it would be what? Dx dy and should be mapping dxi d eta, right? So for this, we should have dx should be equal to what? Dou x by dou xi dxi plus dou x by dou eta d eta, considering total differential. Similarly, dy is equal to dou x by dou xi dxi, sorry, we are written dy. Here will be dou y by dou eta d eta. So this can be like written in this form, and this would be equal to what? Dou x by dou xi dou x by dou eta and dou y by dou xi dou y by dou eta. I think I can do it hopefully. And if it is Okay, dx, dy, dz. So this would be directly equal to, this should be dou x, dou eta, dou x, dou zeta, dou y, dou zeta, sorry, eta, dou y, dou eta, dou y, dou z by dou y, dou z by dou eta, dou z by dou zeta. I think this should be a thing. But the option it matches, it's okay. Yeah, so I'm just getting the transpose of it.
I believe it's
No?
because we don't define transformation correctly.
Okay. Like, is it like, have I done something wrong?
No, you just you
Or
do
maybe it
it's from it's dzi. It should be transformed
maybe
from dzi d eta dzi to dx dy dt because
it
it's
could be like
transformation from
dx dy. It would have been written like j transpose of dz d eta d zeta. Like, this thing has been called as j transpose. Could be, I don't know. Is it? Then if I transpose, then j would be equal to this thing only. Out of these two options, we can say for sure this option is the only correct answer. Because we need to differentiate x with respect to xi eta. X, y with respect to xi eta zeta. Yeah. Okay. Now next question. Suppose we are interested to solve three-dimensional heat conduction problem where the only unknown is the temperature. In order to solve the problem in FEM, the three-dimensional domain is discretized with 8-node weak element. The elemental stiffness matrix can be written as. We'll just skip this because it's there in the assignment rather than I've already given one answer, so I'll just skip this thing. And this one also. Okay. Let's see. I would choose question 5. B. Tell us at question 5B. Why? I already told you that our mapping is from xi eta zeta to xyz. Kapil?
Yes, but it's like changing variables in the integral, right?
Yeah, we are changing variables, but okay. Because I myself feel a lot of confusion, like what is going on. So normally I solve it using solid mechanics thing. What I do remember, like normally you do know that this thing, you know, right? Px is equal to f dx, where f is.
No. For
You
suppose we
remember
have
this thing?
integral. Yes, but it is in solid mechanics. It's some it is corresponds to metric spaces.
No,
Like
but but that transformation thing is still applicable for this thing also. That's what I want to say. Dx equal to f dx. When we see this in the like volumetric thing, this would be like dv is equal to determinant of f dv. this is applicable.
I'm just trying to.
And this,
Okay.
yeah, please look this because this will be
Yeah.
helpful. I
Yes.
myself was still lot concentrating this. That's why I try to remember that Jacobian is what it's a ratio of volumetric deformation, like deformed volume upon original volume. That's the way I try to remember. So
Okay.
what we'll have like in the new mapping is from uh, xi eta theta to xyz. So that's why dx upon dz I think should come for Jacobian.
Well, what is my confusion here?
For one by one,
My confusion here is because it is defined like transformation from master domain to the physical domain. I understand it's like we have some information in terms of it in terms of master domain coordinates like xi, eta, and zeta, and we need to transform it to xyz. Do I understand?
no, what do we have
What?
normally for finite element method or any problem? We actually have the physical domain. We try to map this thing first to
Master
not
domain.
domain. Yeah,
Yes,
current
pardon
domain,
me.
where we use the integration, so that integration will not easy. Now we again switch it back to the physical domain to get the actual values. That is what we normally do, isn't it?
Yeah, this F it's confusing thing here.
No, that's why I'm saying,
Transformation.
uh, yeah, try to see this thing, this approach.
Okay.
It already said like it's mapping from xi eta zeta to xyz. So that's why I tried this approach.
If excuse me,
It's just
if the transformation,
yeah,
if the transformation was from the physical to the parent, I think then it will be choice B, right?
yes,
What does it mean?
yes.
I still I'm not clear here. If we have a transformation from parent domain to physical domain, it means that we have some function in terms of parent domain coordinates, right? Or we have some
Yes.
function in terms of
So we
xyz.
no
For instance,
we have some
we need to
function.
integrate x squared plus. Okay, we need to integrate a function
Okay.
x squared
So
plus xyz along the volume.
we have
For
a
instance,
function f which is having like
xyz.
x y z, which is a function of xi eta zeta,
Yeah,
xi eta zeta, xi eta zeta. Like f is a function which maps xi eta zeta to xyz, right? We have the coordinates of xi eta zeta. We know the xi eta zeta values. We input those values to this f to get the physical values, physical domain values xyz.
okay. I need to look it in math books actually. Yeah, let's move on.
Okay.
Thanks.
Okay. Okay. Let's see this question. Question number 9. Three-dimensional isoparametric mapping. 8-node brick element is mapped to a cube of 5 mm in physical domain. What will be the determinant of Jacobian of this mapping? So this is what I just told about. Let's see you guys can give answer to this question. In a three-dimensional isoparametric mapping, 8-node brick element is mapped to a cube of 5 mm in physical domain. What will be the determinant of Jacobian of this mapping? So, no answers yet.
If we use the last result of last, it should be 8 divided by 125, as I understood.
I don't think it's connected though, but let's see if you're saying about this. No, see, it's parent domain. You're saying parent domain has a volume of what? 2 into 2 into 2, that is 2 to the power 8 units, isn't it? 8 cubic units. In this question number 9, 8-node brick element is mapped to a cube of 5 mm in physical domain. So physical domain has a value given as 5 mm. Cube of 5 mm. So volume would be what? 125 mm cube. And earlier we see, if we try to connect the previous question, their parent domain has a volume of what? It was 8 mm cube. If we say, just say 8 mm cube. So Russell is saying now 125 by 8. 125 by 8, you see. Okay, so Jacobian, I said it would be like the found volume upon original volume in that perspective, and our new volume is physical domain 1, isn't it? It's mapped to physical domain. So volume of cube in physical domain upon volume of 8-node element in parent domain. This should be correct thing. So given thing is volume of cube in physical domain is 5 into 5 into 5. Actually, if I see just this question, this thing is not provided. Volume of 8-node brick element in parent domain. So with regards to that, if we just see this question, given question, it will be cannot be determined with the provided data. Okay. But if we consider, if we try to connect it with the previous question, considering question number, it was,
Sorry, could you repeat why
Five.
it is cannot be determined?
okay, I'll try to, okay, so don't see this question number 5. Don't try to connect this question 5 now. This question 5 was what we used, that physical domain has a volume, sorry, parent domain has a volume of what? 8 units, isn't it? 8 mm, isn't it? So if we don't see that question, consider only this question. Question is, in a 3-dimensional isoparametric mapping, 8-node brick element is mapped to a cube of 5 mm in physical domain. So 8-node brick element is mapped. It's saying 8-node brick element. It is not saying whether it's in the natural coordinate.
So, okay. It can be brick. It can be general brick.
Yeah. Yeah.
Sorry. I believe no brick. Brick is mapped to cube, but no brick is our standard parent element. It's not like
Yeah, so natural coordinate system is, yes, yes, yeah, you got it right now.
so I
Eight
believe
element, it's
if we have
not
all brick
stating
element,
that it's
it's standard brick element. It's like -1 to 1 in each dimension.
yes, yes, but that is to be specified because 8-node brick element we can also use like -2 to 2, -2 to 2 in all the three axes.
Okay, okay.
That is
But
also
when
8-node brick element, isn't it?
when we use a parent domain, it's quite standard, isn't it?
But there is no mention of parent domain as well.
Okay, I agree.
Yeah. So that's why if we see this question only, so in that regard, it cannot be determined with the provided data. But if we consider like question 5, there the parent domain was 8 mmq. So with that, our finding would be this. So 2 by 2 by 2, it will be 125 by 8. Okay. I hope it's clarified now. Can we move on? Okay. I hope others are also satisfied. Jis and Abdullah.
Yes.
Okay. Okay. This is the last question for the assignment number 12. So I'll not solve exactly, but we can see like how will it be solved. Yes. Okay. So what will be the value of integration with 2 by 2 by 2 point quadrature of the following integral? And we have this function. So we have 2 by 2 by 2 point quadrature of the following integral. This you guys need to solve it. So suppose this is f y theta zeta. So I would be what
We just
we are given with -1 to 1 f psi eta zeta
could you please
dx
provide
dy.
us? Sorry, could you please provide
There
a
is
correct?
something wrong.
No, it's correct.
Correct what?
Dy dy. It's because it's not
Yes.
multiplied by Jacobian.
Yeah. So this creates a confusion here
We
because
need to
it's not
multiply by
stated right
Jacobian
what will
also.
no, but what will be the Jacobian? You
It's
can't do this. So let's treat this as d psi d eta. D psi d eta d zeta. Okay. So for this, we'll just
now
do what? Because I don't think there is a misprint. I do think that it should be d psi d eta d zeta. Okay. Then what needs to be done is we have 2 by 2 by 2 point quadrature rule, right? So total it will be what 8 points, and in all the three axes we are following 2-point quadrature rule. So it will be w. Okay, I'll just write like this: wx, wy, wz 4.1. Okay, and this would be like xy1, eta1, zeta1. Similarly, wx, wy, wz. These are like weights for node 2, and this would be not node 2, cos point 1. Then would be point 2. Similarly, will follow till cos point 8. That is wx, wy, wz, 8, f, 8, theta 8, theta 8. Okay, and we'll see you guys must be knowing already that in a 2 point quadrature rule, this wx, wy, wz all equal to 1. Okay, so you won't need to pay too much attention to this weights. So it will be like just summation of f y1, eta1, zeta1. So you just need to know what will be my y1, eta1, zeta1, and similarly till y8, eta 8, zeta 8, and substitute those values in this function given values and add it. And got it?
Could you please
That is
provide
following.
us with with correct Google inquiry when
Answer.
we need to see a table with these points and with weights? I'm just I can find this information for one-dimensional integration, but how I should use it for multi-dimensional
Okay.
integration? Where because in the lecture it was provided, these tables were provided, but I cannot find this on the web by some reason. It might be I'm
No,
very bad
it
in
will be like
Googling.
it was big order and sampling points. It must be written this. Okay, let me see. Let me see and share it. Okay. Okay, so I'll share my screen now. See, I typed in the search box order.
I cannot see your screen, by the way.
Let me share it again. Uh, Is it visible?
For me, it's no.
Oh,
Oh, visible.
yeah. Is it now? Yeah. So
Yeah, right
if
now
you see,
it's okay.
I just okay. So I just got order of integration using Gauss order. That's it. And I just take down this image one. So now just this table is what we have.
This Gaussian rule quadrature overview should be. Oh no, numerical factory also might be interesting. And Gauss quadrature rule. I asked because in the lecture it was so nice examples with these tables. There was really nice examples, with very accurate tables. But I
So normally we see one and two number of points like first quadrant, first and second. We hardly go to three. So the problem you are facing, what the problem you are doing it. It's quite problem dependent what we are going to take.
so you can
So
use okay, you can use this for multivariable also, or this table.
yes, yes. So see, along x, along y, along z. Okay. You just see this table. As of now, you can take the snip if you want.
I see.
Plus minus. Okay. Okay. I'll tell you how is it been done. Okay. Okay. Let me do this. No.
Since we have two point quadrature rule for each direction, the weights will be the same for each point, right?
Yes. Yes. But if it had been what I was trying to say now, like if it had been like just see only in two coordinate systems. Okay. D is I and d eta. Like let's see only in xi eta coordinate system. Xi eta coordinate system, and we have 2 by 1. This is just arbitrary. Okay. 2 by 1 quadrature rule we are following. Okay. So this implies that in the xi on xi axis we have two Gauss points. Okay. And along the eta we have only one. Okay. So if we multiply total like xi eta thing, let's draw this domain. Okay, so with this first thing, this says that along xi there are two Gauss points here. Gauss point quadrature rule we following, and along eta only one Gauss point quadrature rule we are following. Okay, so if we see the table, if we have a two Gauss point, so the point of location for this Gauss point is minus 1 by root 3 and plus 1 by root 3. Okay, and if only one Gauss points are there, we have the coordinate for that is at 0. Okay, now see, it's 2 by 1. So total Gauss points for this xi eta coordinate system, this is xi eta coordinate system, will be what? 2 times 1, that is 2. There are only two Gauss points throughout this domain, and location would be, so location would be first Gauss point location would be, it is having a, okay, I should write this minus 1 by root 3 and plus 1 by root 3. So first Gauss point location would be in xi eta coordinate system minus 1 by root 3 comma 0, and second Gauss point coordinate will be plus 1 by root 3 comma 0. That is minus 1 by root 3, that it will be here, somewhere lying here, and second one will be here. So if I write it like first and second, okay. So for this, if I try to solve, if I try to find integral, I say it will be what? At first, it will be having a weight function corresponding to xi, okay, xi coordinate system. We are looking at first Gauss point, and with respect to eta at this and f xi 1 eta 1, okay. So we have to add the other one xi eta for the second Gauss point as xi 2 eta 2, and if you know, you already know, like if it is a 2 Gauss point, the weight function corresponding to that is 1 1 weights, okay. And if it is only one Gauss point, if you see that table, if it is only one Gauss point, location is 0 and weight is equal to 2, okay. So in the xi coordinate system, if you are following two order, so weight is equal to 1, eta is equal to 2, right? And this would be at value minus 1 by root 3 comma 0. Similarly, for the node second Gauss point, it will be, for with respect to xi, it is having a weight at 1. For eta, it's 2. And function evaluated at 1 by root 3 comma 0. So this is what my integral would be finally. 2 times of f minus 1 by root 3 comma 0 plus f 1 by root 3 comma 0. So the thing which I have told is just for 2 by 1 Gauss quadrature system. 2 by 1 Gauss quadrature system. The question asked in this is 2 by 2 by 2. Like 2-point quadrature system on all the three axes. So you have to multiply the weight corresponding to all the three axes, x, y, z, and add for all the 8 Gauss points. Okay. This is where we can stop the questions regarding assignment number 12. I think you guys have got a lot of help regarding assignment 12. Now we'll just discuss the solution of assignment number 11 as quickly as possible, because we have already discussed last time also. So let's do it quickly. So the question is, suppose reduced integration scheme is follows to calculate element stiffness matrix for a Q for element. What is the rank of element stiffness matrix? So you guys can give answers quickly. Yeah, so it's 3, because total degree of freedom is 8. We have 3 rigid degree of freedom and 2 hourglass. So it will be having rank as 8, 3 minus 2, it will be equal to 3, right? Next question is, suppose in a finite element approximation 3D brick element is used, how many numbers of rigid body mode should be taken care? Yeah, so this also answer is option D, 6, and modes are all the translation. We can say UV, and rotations in both all the three axes, theta x, theta y, theta z. Okay, or rather I could have written ux, uv, uy, uz, theta x, theta y, theta z. Okay, so it's total 6 degree of freedom. What if this had been like for Q4 element? What will be number of rigid body modes for Q4 element? Yes, uh, for Q4 it will be 3, and it will be like ux, uy, theta, z. Okay, move on to the next question. In case of selective reduced integration scheme for bending of a thin cantilever beam, what of the following option is correct? First is shear logging can be avoided by taking reduced integration for bending stiffness and full integration for shear. Shear logging, second is shear logging can be avoided by taking full integration of bending stiffness and reduced integration for shear. Third is shear logging can be avoided taking full integration for both bending and shear. And fourth is selective integration has no effect. So the answer was option B. We need to apply full integration for bending stiffness and reduce integration for shear stress to remove the shear locking thing. Okay. Fourth question regarding assignment 12. So yeah, question is choose the incorrect option from the following statements. First statement is reduced integration scheme provides rank deficient element stiffness matrix. Second statement is in case of Q4 element number of hourglass modes is 2. Third is according to Oliver Bernoulli both bending and shear deformation arise a significant amount. And fourth is lower order element with full integration who cannot efficiently approximate bending problems of thin beam. So last time we had a lot of huge discussion in this. So we, we quite familiar with this thing. So answer would be option C because according to Euler Bernoulli, bending is more dominant compared to shear deformation. So shear deformation is negligible in Euler Bernoulli beam theory. Okay, so on to the next question. Okay, so this question we can actually calculate. So question is suppose there is a cantilever beam of length L, thickness H and width 2D is subjected to a point load 2P at its free end. The beam is discretized with single element and linear polynomial is used for approximation of dynamic field variable W and theta. Consider total strain energy as UV plus ES where UV and US is bending and shear strain energy respectively. Okay. So what will be the expression for bending energy of the thing is the first question. So rather solving specific, we can just first write what will be the total strain energy and then write what will be the potential energy. Okay, so given question is we have a linear polynomial approximation for both W and theta. And we have the degree of freedom as W1 theta 1, W2 theta 2. So first thing, we have a linear polynomial approximation that is 1 minus x upon L W1 plus x by L W2, and this is at x theta as 1 minus x by L theta 1 plus x by L theta 2. As we can see, W1 theta 1 would be 0, W1 theta 1 equal to 0. So this will imply that W is equal to x by L W2 and theta would be equal to x by L theta 2. Yeah, Rafal, you have raised a question. You want to add something?
I want to add to this. On the week, I looked through the Timoshenko book in theory or devoted to theory
Okay.
of elasticity, and there for cantilever beam, there it was said that there is no condition for cantilever that theta is equal to 0 along x equal to 0 line. We can only have phi is equal to 0 on the point in the point x equal to 0, y equal to 0, not along the line.
No, in this question, if you see along x equal to 0, it's a fixed beam, right? It's a fixed cantilever beam.
Yeah, it's absolutely
If
clear
you're
for
saying
me.
cantilever beam, that
But in theory of elasticity, in previous week when cantilever beam was considered, we um, we just compare cantilever beam solution with analytical solution in the lecture. Okay, and there in cantilever beam solution, lectures provided a book Timoshenko, and I looked
Timoshenko
into
and
this book.
Goodyear.
Yes. I looked to this book, and there for cantilever beam, it was said that we cannot, in theory of elasticity, we cannot assign condition theta is equal to 0 along line y at along line y in the point where x is equal to 0. We cannot, in theory of elasticity, we cannot guarantee
Okay.
that.
I got your question. Yes. I got your question. Okay. So, this is regarding theory of elasticity. That is like digressing from the discussion. Okay, I'll talk to you in that regard. So, this is what is there. In reality, we have x as this, y as this. Okay. So,
Yeah.
what are all the boundary conditions we normally take? What are the boundary conditions we take for this case?
Boundary conditions
I'm
for
just
cantilever beam.
asking displacement. Yes.
For cantilever beam or for cantilever beam in theory of elasticity. For Euler Bernoulli, we
Yes.
just say y is equal to 0, y prime is equal to 0 at point 0.
Y equal to 0
At y
at
at
x equal to,
yeah, and y prime is equal to 0.
or I would say not y,
Yes,
deformation in y is
v
equal to 0,
and v prime or
v0
theta
at x equal to 0, and
theta.
v prime is 0 at x equal to 0. Okay, theta. Okay. So, okay, you're saying this thing. So this
Yes,
is
in theory of
imposing a very
elasticity.
strong condition. So yeah. So if I say v equal to 0 at x equal to 0, so does it mean it is 0 at only at every point?
No, in theory of elasticity, I am sure about. In Timoshenko beam, it's my main confusion for this week. But I'm absolutely sure that Timoshenko assigned only at the point. You can check.
Yeah. So this is yes. So I'll tell you. Depending on the problem, normally what they take is some people will take only the boundary conditions are imposed. Like normally, what is solved when it is solved analytically, they will integrate it and they will have a constant of integration, right? When there is that equilibrium equation is there, it's a differential equation, right? When you will integrate it, you'll have a constant of integration. To remove those constant of integration, we substitute the boundary conditions. And what people normally do is first thing, like one way they take is they will impose these condition at this point at x equal to 0 and y equal to 0. Okay, one way is this. Other way, they will impose this condition throughout this in a rough way, like in an average sense, like
In which
summation
sense?
of v equal to 0, like uh, in the sense
My
summation.
look. My question is here. Even if we see if we look into the theory of elasticity, there's no analytical solution for cantilever beam. Well, I mean, for boundary condition, if we want to have x is equal to 0 or v is equal to 0 and prime is equal theta is equal to 0 along the line, there is no analytical solution in theory of elasticity. Am I right?
If I remember it correctly, it depends on the third boundary conditions, like what problem you are solving and what boundary conditions you are taking.
Look, I integrate everything. Like I substitute bending stress, and this stress we discussed last week. Shear stress, parabolic shear stress, parabolic shear stress. I add them both, differentiate coordinates like epsilon x6 is equal to dy dx, epsilon y is equal to minus Poisson Poisson constant multiplied by sigma x divided by Young modulus. And I also take shear stress definition. I integrate everything, and after integration, I cannot use this condition where in mathematical way there's no how to describe this condition. X is equal to 0. When x is equal to 0, we have a boundary is equal to 0. It as I understood, this problem will be over constrained if we assign the whole line is equal to 0. So my question is there a solution?
Okay, Rafael, I'll just I'll implore you to search this first problem I've written down
Could
and
you please
look.
Kirsch?
Uh,
Kirsch?
yeah,
The third letter is R.
KIRSCH, if I'm correct.
Okay.
Let me check it.
Okay. I Google it.
This problem.
It was my it was surprise for me that a theory of elasticity doesn't have solution for cantilever beam. It was for me
No,
when
no,
we
no.
assign
Okay, what I said is not applicable for this one. This is like for plate with a hole. Okay, I don't remember the name for the problem. What was?
I looked
Uh,
through several books. My question is to when lectures were provided, there we could see that we have an analytical solution and we have a finite element solution. The lecturer compared both
yeah.
analytical and finite element, but there is no analytical solution of theory of elasticity in theory of elasticity book. So I believe they used Euler-Bernoulli equation
I
in the
don't
lecture.
know. I can't.
I asked
I
on the
come.
forum,
I
but
can't.
the, I
I
asked
can't
this
comment
question on
because
the forum.
I have not seen those things, so I can't comment.
Okay. It was surprise for me that theory of elasticity is useless in this problem.
No, I think it's there, but it depends on what boundary condition you are imposing. Like as you have just said now, that if you are over constraining to make everything equal to zero along that line, so it becomes difficult to solve. I I don't know.
But
I don't
how
remember.
we how then we compare finite element solution with analytical? What we
Okay.
take for analytical solution?
See, for every problem we don't have analytical solution, that you can agree on, isn't it?
I asked on the forum what did they take as analytical solution, but there are no answer. It was no answer.
I,
Yes. So my
okay,
question is
okay. You
still
you you can
active.
directly search in the using the Google, like what is the analytical solution to this problem.
Look, I ask you because several days I was on that
Okay,
because I was really interested how to obtain analytical
okay. So
solution for cantilever
the
beam.
problem is this cantilever beam. We
Yeah.
are providing a load here, and there is a analytical solution. Is it, or the problem?
There is no
Uh,
analytical solution if if there is analytical solution if only we consider that u is equal to zero and v is equal to zero at the point. If we have this, we can assume also that our gamma or shear deformation is equal to zero at this particular point.
hmm.
But in this solution, our uppermost layers are deformed, so there is no cantilever. In the sense of cantilever, there is no there are displacement on the upper layers.
Okay, you're
So
saying at this point.
yes, we have displacements there. So my question is, if
That's actually I said in an average sense. What I was saying earlier, that rather imposing at every point it's equal to zero. Some people take at this point. Some people take at this point, impose this boundary condition at only at this point. Some people take in an average sense.
what
In
does
an
it mean?
average sense, what does it mean? It's u mean is equal to zero. You mean we mean it's equal to zero. It means suppose the topmost point is having a slight displacement in the top. So there
Okay.
could be something like at the this bottom point must be moving slightly down. So it's in an average sense, this complete thing would be equal to zero, isn't it? If it is equal.
I'm thinking. I'm
I'm
pondering
just
about how
saying,
to.
you better explore it. You better explore it because I have
Okay.
read about these kind of cases. I don't remember exactly, but I do remember that this kind of this
Okay.
depend on the boundary
Thank you.
condition how we are
Thank
including.
you. Thank you.
Yeah. Okay.
Very interesting question, by the way, for me.
Yeah. Actually, if you see, there is a question. There is one more thing. It depends on, like, if you are applying a point load here, so is it at the top surface or is it at this surface?
In theory of elasticity, the boundary condition for this P is integrate of tau along the surface is
Yeah,
equal to
yeah.
zero.
That is also one thing you need to see, isn't?
Okay, but in the finite element method, in the finite
Yeah,
element method
you.
programs, we took as a point load.
Yeah. You got it now. Okay.
Abdullah should agree with me in this. He definitely has his point load on Abacus.
Okay. So coming back to the question now. Uh,
Yeah, let's move on.
so okay. So we have. Okay, we'll just solve 15 now because we are moving with having less time now. So we'll solve it quickly. Abdullah is saying I'm lost. Okay, we are coming back to the question now. Uh, Question corresponding to question number 15. So we had a linear approximation for displacement as well as first slope, and W1 and theta1 it's 0. So W is equal to x by L times W2 and theta is equal to x by times theta2. Okay, we need to find bending energy of the beam UB. So UB will be equal to what? EI by 2. We have to integrate it throughout the domain 0 to L, and uh, d theta by dx whole square dx, and it is equal to EI. I is equal to what? BD cube by 12. In this question we have B is 2B, 2B, D is H, H cube by 12. Okay, so this is equal to I is equal to what? B H cube by 6. See if I'm doing correctly. Yeah, H cube by 6, BD cube by 12. Okay, so we have here E P H cube by 6 by 2, 0 to L. D theta by dx would be what? Theta 2 by L whole square dx. This is E B H cube by 12, 0 to L, theta 2 L square. These are constant, theta 2 L square, and dx times it will be integrated, it will give me L. So this is equal to E B H cube theta 2 square 12 L. This will be my bending energy. EB H cube theta 2 square by 12 L. Okay, so this will be the answer. What will be the next question is what will be the expression for shear energy of the beam? Consider Ks as shear correction factor. So this will be found using US is equal to Ks G A by 2 0 to L uh, d theta dw by dx minus theta whole square dx, and this would be equal to Ks G A is what BH by 2 0 to L dw by dx, it will be equal to W2 by L minus
2B.
theta. Huh?
2B is there.
Area is 2BH.
2BH, yes.
Oh, okay. Thank you. And this is theta is x by L times theta 2 square. So dimensionally it's correct, yeah. So dx. So this is Ks G dx W2 from L square minus 2 W2 theta 2 L square x, and plus theta 2 by L square x square dx is correct. So US would be equal to what? QS GBH. This time will have this is a constant. W2 square, this will be x in connotation x, and if you put the limits, it will be directly L. Okay. Now this x square by 2, so that will give me W2 theta 2 by L square, and putting the limits, it will be L square plus theta 2 square theta 2 square upon L square, and that will be x cube by 3. So that will give me L cube by 3. Okay. So let's see. Let's simplify it. US equal to KS GBH W2 square upon L minus W2 theta 2 plus uh, theta 2 square L by 3. Theta, okay. So we have, if we see theta square L cube by 3, theta square L cube by 3. So let's take, I can make this as KS GBH by L square. So this will be equal to W2 square L minus W2 theta 2 L square, and this will be equal to theta 2 square L cube by 3. So first option would be correct. Yeah. Yes. So first option is correct. Okay. So what will be the expression for the potential energy of the beam? It will be the force applied is 2p here, and it's like opposite to the load W2. So 2p W2, but uh, okay. So the question, as we have got, like, what will be the expression for the potential energy of the beam? So it will be equal to UB plus mu S, and it will be equal to, we have the load 2P W2. So with that, our answer would be EB H cube theta 2 square 12 L, it was, right? Yeah, this one, option C. Okay, I'll skip this question, but we can, you guys can solve it. For this, what you need to do is, we have phi as this expression. We need to just solve dou phi upon dou theta 2 equal to 0 and dou phi upon dou W2 equal to 0. With this, solving these two equations, we'll get the value of theta 2 and W2. Okay. Question number 19. Choose the incorrect option from the following statements. First statement is volumetric locking in a body can be eliminated using only full integration scheme. Second statement is incompatible modes can be used in lower order element to approximate pure bending curvature. Third statement, volumetric locking in a body can be observed if its position ratio is close to 0.5. And fourth statement, for a Q4 element, there are three deformation modes for which strain energy is constant. Uh, I'm seeing the statement right now, Rafael, you have written after that sort of questions. I want to give up with mechanics. Is it like after that cantilever question?
Yeah. It's related to that. Continue the question.
Okay. What about this question? What is the correct answer? Okay, Abdullah is saying option A. Nicholas also said, Vijay has also said, yeah. So as you guys have already studied in the lectures that uh, volumetric locking can be eliminated using selective reduced integration. So this statement is quite wrong. So let's move on to the last question for today's session. This is choose the incorrect option from the following statement. In a cantilever beam bending problem, if the beam is discretized with Q for element, undesirable spurious shear energy will be introduced within the element. Second statement is volumetric locking can be eliminated with the bar method. C third statement, for a Q4 element, there are three rigid body modes for which strain energy is non-zero. And fourth statement is in case of B bar method, strain displacement matrix is decomposed in volumetric and dielectric part. So answer. Yeah, so everybody has given answer as option C. Yeah, so with, for this, actually, there are three rigid body modes for which strain energy is zero. It's not non-zero, it's zero. That's why it's called spurious. No, no. For rigid body mode, we get a strain energy as a zero too. Okay. Uh, about the first, second, and fourth statement. Let's see. In a cantilever beam bending problem, the beam is discretized with Q undesirable spurious shear energy will be introduced within the element. Okay, so that is quite correct. Second is volumetric locking can be eliminated with B bar method. Yeah, and to do that, we decompose the strain displacement matrix in volumetric and deviatory part. And in the volumetric part, we make those changes and take bar instead of actual strain displacement thing. Okay, so this completes today's session. If you guys have any doubt in like any other thing, I'll just go through like for assignment will what is required. So I don't think you guys will have any doubt in this kind of question. Neither in this. It's better to see more closely in this question. And yeah, so this is like helpful for like if different in this like it's 2 by 2 by 2 in all the three axes. If it had been like different in all the three, you guys need to see quite. You need to see like what will be the width and what will be the location pertaining to it. You guys need to see and substitute those values properly. Okay. Uh, Anyone has any doubt regarding today's session?
I have a question.
Yeah, go for it.
What we're going to do for the next session?
Okay, so in the next session, first thing will be doing is in the next session, assignment 12 will be discussed. So assignment 12 will be consisting this question, so that we can uh, complete it like in half an hour quickly. half an hour or 45 minutes if you guys join in the right time. Then we can work on the code which you were saying earlier, or other doubts if you guys have.